Buildings as power plants in smart grid, transforming a city CBD block into a microgrid by readapting a disused electricity substation building. The principle of this research is to propose a concept of a small-scale energy distribution network with renewable energy generation in a city CBD area. The research of technology will include smart grid, combined heat and power generation, on-site waste-to-energy plant, automated vacuum collection system, electricity storage facilities, plug-in hybrids, clean local energy generation, which will allow buildings to be contributors as well as consumers to the electricity grid at a precinct level. Electricity is generated from power plants, from both fossil fuel and renewable resources. It is delivered to consumers through transmission substations, transmission lines, and transformers, the whole system called an electricity grid. In traditional electricity grid, power is generated from a few big central power plants. Then it is being transferred through transmission network to consumers. It is a highly centralized system with large-scale generation and vertical integrations. In current developments, the electricity grid is getting decentralized into small-scale distributed generation, but with broken integrations. Big power plants generate electricity in an even rate. Increase or decrease the supply takes time, and it is impossible to change the supply rate on a daily basis. But our daily electricity demand varies a lot. The electricity demand is relatively low during the nighttime and early mornings. The load reaches its peak during the daytime. The only commodity is the need of instant equilibrium between demand curve and supply curve. One of the big problems we are facing now is that the increased load demand at peak time beyond the capacity of the wires in the grid. So increase the off-peak time electricity load and decrease the peak time load is a key movement towards energy efficiency for current situation. Smart grid brings more opportunities for energy efficiency development. Distributed generation and storage is a key component of the smart grid requirements. Small-scale and local generated power from renewable resources will reduce the increasing pressure of the peak time load on the existing power grid. In smart grid, consumers are transformed from passive users to active participants. They can save energy by choosing what devices to use and when to use them. They also have the ability to generate power. Each individual building is a power plant in smart grid. Electricity can be generated locally through renewable resources, such as photovoltaic panels, small-scale wind turbines, and fuel cells, etc. The excess electricity then can be stored in batteries, hot water storage unit, and charge electrical cars in off-peak time, all trade with the grid. We are more energy efficient when we encourage consumers using more electricity in off-peak time and less electricity in peak time. Customer opportunities in smart grid includes energy-efficient building systems, customer portal and building energy management system, advanced metering, control interface, smart end-use devices, distributed generation and storage, plug-in hybrids, smart energy consumption, smart homes, smart buildings, building automation and control systems, etc. Smart grid integrates high-speed communication technologies with the electricity grid, allowing for real-time two-way communication between the utility, the consumer, and throughout the distribution grid. A smart grid can identify and resolve faults on the electricity grid, manage voltage, and identify infrastructures that requires maintenance. It means that, for example, whenever there is a blackout, nobody needs to call the control center, but the system can transfer the information automatically, and the cable is able to self-healing. Smart energy production, smart homes, and cogeneration plants are well developed in many European countries and in United States. Here are the maps of decentralized power supply system in Denmark and in United States. Cogeneration and smart grid are relatively new in Australia. The city of Sydney has rolled out an energy master plan to reduce greenhouse gas emissions. The city of Sydney has started the decentralized energy tree generation, renewable energy, and alternative waste treatment master plans. The tender for the tree generation systems is already in process. There are 5 tree generation plants in individual buildings. 10 to 15 new tree generation plants will be installed in Sydney CBD area for energy distribution network in the coming years. In tree generation plant, the engine runs on natural or renewable gas and produce low carbon electricity, heating, and air conditioning for clusters of surrounding buildings. Renewable gases are generated from household waste, agriculture byproducts, and sewage. But at the moment, all tree generation plants in Sydney area are using natural gas, and the natural gas is still fossil fuel.